Above all, Industry 4.0 faces the challenges of the fourth industrial revolution using cyber-physical production systems. A new decentralized intelligence generates networking and independent processes. The interaction of the virtual and real production world is a crucial aspect in the manufacturing process. Industry 4.0 is paving the way for a complex technological revolution that will drastically change the entire value chain. Germany is leading in the fields of production technologies and engineering. We employ 1 million people in the sector. We have another field of expertise which has remained fairly unnoticed. We are also leaders in embedded systems. Strictly speaking, embedded systems are software components embedded in industrial products. Industry 4.0 connects the two fields of production technologies and smart production processes within products. The Kaiserslautern-based lab center Smart Factory tests the communication between product and machine. The RFID label on the empty soap bottle tells the robot which soap it has to fill into the bottle and which bottle stopper it has to use. The smart product knows everything about its individual configuration, its customer, and its destination. The soap bottles with white stoppers have different destinations than the soap bottles with black stoppers. Actually, Industry 4.0 is a paradigm shift. We aim to gradually decentralize centralized production control. Simplified, the workpiece itself is giving the instructions. It addresses the robot directly. Please paint me red, or I need grinding here and there. Developments that constitute a reversion in the logic of producing. In the future, components such as the Bosch diesel injector will be produced in small quantities and in real time. The production starts only after somewhere in the world a car maker has actually placed a concrete order. The order form not only contains all information about technical requirements, but also about destination and client. The information is embedded in the component and is capable of managing the production process, for example, by ordering missing components. Simultaneously, customers are kept informed of the current state of production. At the end, however, an employee makes sure that the product really fits into the engine of the car maker and checks for errors that may have occurred. If everything is fine, the customer will be informed that the product is ready for shipment. Direct communication between partners in a supply chain is of crucial importance, particularly in volatile markets. That's why we focus on improving communication technologies. Intelligent sensors are able to determine the current location of the diesel injectors. They know the recipient data and are able to find the destination, almost by themselves. The system is supported by a complex software, future generations of which will be developed in the SAP Future Factory in Dresden. The software translates the information into clear and meaningful images. The packers receive permanent instruction on what to do, and occurring errors are reported automatically. The new system aims to support people in their efforts. The images, for example, can help to bridge language barriers, as they are easy to understand and to remember. Smart production systems, however, are still in their early stages. Future machines are expected to check technical data, such as filling levels of coatings and paints, or oil and coolant levels themselves, and to report the results automatically. Via internet, the plant would be able to inform service specialists all over the world that action is needed. Experts would have access to detailed error reports, and service engineers could be sent to check the robot on the spot. New opportunities, however, call for new solutions. Just the simple process to recognize a box on a workbench requires a complex technical system. The interaction between sensors and software. Comprehensible visualization generates an incredible amount of data. As the system is required to interact even with mobile devices, security breaches are needed in order to prevent that every smartphone is able to control the machines. It will be a major challenge to guarantee the security of the system, from the sensors to the applications. Apart from security aspects, the huge amount of data will play a decisive role. We have to think about efficient algorithms that are able to deal with the large amounts of data and events, and to transform the data into meaningful information. Even today, software plays a key role in industry. Individual machines are designed on a computer and tested virtually for functionality before being produced. That's why companies such as Siemens are already spending nearly 50% of their research and development budget on software. About 17,000 of the 30,000 researchers at Siemens are software developers. Even entire production plants and processes are designed in a large scale on the computer. Processes are simulated and tested before plants are built, thus saving time and resources. Thus, we are able to reconcile competitiveness and environmental responsibility within modern production systems. Furthermore, the market for industrial software with a volume of 15 billion euros and an annual growth of about 8% is very attractive to us. Modern factory planning also takes the environment into account. The Wittgenstein Bastian company set up a noiseless and emissions-free production facility in a residential area. Short distances to work are advantageous and will enhance flexibility in production. Land is much more expensive in a city than in the countryside. Nevertheless, we set up the production facility here because our employees live in the area and appreciate short distances to work. The buildings in the neighborhood require heat. We have excess heat due to production, so we can make our excess resources available to our neighbors. The atmosphere in the facility is friendly and clean, similar to an office. Staff that feel comfortable work more efficiently, and employees that live nearby are more flexible. The filtered air is provided by a highly efficient system under the roof. In the future, the smart production systems and the air conditioning system are expected to communicate independently. Take, for example, this intelligent system of our heat recovery facility. If we were able to connect the heat recovery system to other systems within our company, we could make sure that steps are taken to reuse the wasted heat in an energy-intensive production process. The wasted heat can then be used when warm water is needed, for example in the morning for taking showers. Actually, this could even make energy a bit cheaper for all of us. Industry 4.0 is a sophisticated approach. The entire value chain is facing profound changes. This means changes in communication, planning, logistics, and production. The main goal is maximizing productivity in all fields. The implementation starts with small steps here and there. There won't be a big bang that is going to introduce Industry 4.0. On the contrary, it will come step by step. But if we look back in 10 years, we will see that the world has changed significantly. It's not only German industry that is facing massive changes. The fourth industrial revolution will affect the whole planet.